Welcome to the Nerves Meetup, everybody. This happens last Wednesday of the month, every month. The Nerves Meetup is sponsored by Redwire Labs. We specialize in putting the beam on hardware. I have a handful of hardware that we do that with. Most of you know the routine here, so I'll skip over this because we've got some cool stuff coming up tonight. Quickly, though, announcements. There are more NurseConf US presentations up on the YouTube channel now, so the Nurse Project Meetup channel. We've got 3 more of those up now, so a total of, I think that puts us up to 5 out of the 8 presentations that happened at NervesConf. So if you didn't make it to NervesConf or you want to review those, go check those out. That's where those are at. And we've got a pretty cool presentation tonight around NxHailo. We've got Vittoria and Paulo is sneaking around here in the audience as well, who's part of this project. So I will hand it over and yeah, Vittoria, take it away, and looking forward to seeing what you got here.
So we are talking about this library called NxHailo, which is basically for running machine learning pipelines on the edge. Before start about me, I am formerly a control systems engineer, but it's been a while. Like right away after I graduated, I started working as a software engineer, and now I am a software engineer at Driver Technologies. Check us out. We are automotive safety software where we basically have dash cams that could apply to like multiple aspects of car safety, and also as a data source for automotive pipelines. We also apply a bunch of computer vision. We don't do edge computing, not yet, but I am being very annoying with our team in order to implement some hardware instead of using mobile phones for streaming video. Anyway, check us out. Website can be a little bit insightful. And I'm also a computer vision student and enthusiast. So probably all the examples we're going to see here, well, all the examples we're going to see in this presentation is related to, it's applied to computer vision problems. So cope with me. NxHailo. NxHailo is a library we licensed, and the main contributors for this library is Paulo, me, and thankfully Frank Hunlett as well. So big thanks to both of them. Paulo is here with us, so if you have questions, ask him, not me. And yeah, how this project started. It was also the beginning of a great friendship, but it started last year at ElixirConf US, where Paulo presented running NX on LiveView Native, because Brian just released like LiveView Native, and it was a great presentation from Paulo on combining those two libraries. And he basically endorsed the idea of using the hardware that we have. So it can be like edge devices, but it could be also our own computers or phones in order to run and execute machine learning computations and not have to rely on like expensive cloud computings where we have to pay for everything. Like right now we see a lot of computers powered with GPUs, so we could leverage more the usage of our own machines, for instance. For some things, not all things. We know machine learning training and inference is hard. Sometimes there's no other way. You need like a lot of computing capabilities, but it was a great start. And that rang the bell for me. I had a Raspberry with me sitting around in my desk, never used. Like I always saw like tons of Nerves newsletter, and people are like, oh, okay, that's a cool project. And I had the Raspberry Pi with me, but I'm like, I never had the gut feeling of like starting the project right away. And I figured out that I'm not alone. I asked many other engineers, and kind of like 90% of them, they have a Raspberry like sitting aside on their working desk, and they have this like future project where they're gonna like implemented something with Nerves and it's gonna be pretty cool. Yeah, but like apparently we are all living with inertia and procrastination. So I decided to beat procrastination that day. Sometimes I regret it, but here we are. And so I had the Raspberry Pi, and I also had it with me, the AI hat, which is a Hailo accelerator on top of it. And I thought about, okay, so let's combine the two of them. Let's use Elixir concurrency powers to run machine learning inference models with NX, and let's use the Raspberry Pi with the Hailo chip, so we can basically run inferences on the edge, low cost. The hardware itself costs like less than 200 USD or way less than that. I don't recall exactly the price. But it's fantastic, right? There are also other types of hardware. I'm pretty sure, like Alex for sure is way, way, way more knowledgeable than I in that matter regarding like types of hardware for that. There is like NVIDIA Jetson, if I'm not mistaken, and other different types of hardware for doing edge computing. But we ended up with the Raspberry Pi, and the AI hat seemed like a good option for starting with edge computation. And also because we had the idea of using nerves with it right away, right? So again, the Hailo AI hat is an acceleration module for the Raspberry Pis. We tested with the Raspberry Pi 5. I'm not sure exactly the support for different versions of the Raspberry. And again, high performance, low power NPU. And the Hailo also provides a Hailo RT, which is their API. It's their runtime API for inferencing. And it comes with Python and C++ bindings. So that is pretty useful every time that we need to call Hailo to load a model or to run an inference. It's compatible with deep learning frameworks. But it has like a detail because it loads neural network models in the precompiled format, which is the Hailo Exchange format. This is pretty crucial because in order for such a small hardware, well, small in terms of not size, but being able to do all those computations, they had a very specific data compiler. So there is this detail that is really important. Like you cannot load any model you want. You got to go through their repo and see the models that you can use in their specified format. And what about nerves? We wanted to compile Hailo RT into a nerve system. We could do it directly using the Raspberry Linux kernel. Yes, we could. But there is already a community behind it. There is a hype behind nerves as well. And we embrace community. And we also embrace pain sometimes. But yeah, we envision having like a full solution using Elixir. So also that's also nerves became a possibility for us. And I'm not that knowledgeable with Linux, so that was also a good deal for me. So anyway, onwards. First, we started building the Hailo API. So that part was mostly Paulo, thankfully, but it was basically creating Elixir nibs for Hailo functions that we need for building the inference pipeline. And that is basically for calling two functions that are mostly necessary for a pipeline, which is the load function, where, well, there are some sort of intrinsicalities here, but we need to create, we need to call, whenever you see API here is the Hailo API, and we need to do those calls. So create device and configure network group, because you can run multiple models in one Hailo hat. So there's this like previous calls that we need to do. And then we also call the API to create a pipeline and load the model, which we loaded, hard coded. And yep, that's really still poorly implemented. And that this loads the model into the device. And the second function where we had to implement on Elixir from the Hailo RT API is the infer, which is basically passing the pipeline that we created before with the loaded model. We call the inputs, we call the API infer, and then we need to parse the output. Most part of the post-processing here and pre-processing here, we implemented using Elixir and NX. So this is really just the most trivial aspect of running the inference model. We will see following the slides, all the pre-processing and post-processing, we try to use as much as possible NX because it's easier. One, because it's our area of domain, and second, because it's easier to compute rather than passing to Hailo for doing that, and faster as well. So creating the machine learning pipeline. For this example, we are loading the YOLO V8 model for object detection, and we call it Vision. Sorry, I didn't added the GitHub URL, but Vision, it's a library built by Coco Shu. I hope I pronounced her name correctly, but it's basically bindings for OpenCV. OpenCV is like a massive library for computer vision. And thankfully, we have a wrapper for doing the OpenCV calls using a Vision. Something appeared on chat, but I won't see it for now because I don't want my ADHD to like interrupt me here. We are using a Vision basically for doing the pre-processing. We need to pre-process the image, make sure they fit into like we put in the proper padding. We also use the Vision for capturing the webcam images and creating the bounding boxes for YOLO to add on the detected objects. And NX is used as a common interface for eVision and NxHailo data exchange. I'm going to show that later. A cool thing that it's on the repo, we ran everything in a live book. So it's not that you need to spin up like a whole project, make sure like this is like the good thing is this is out of the box in terms of like you can test it and demo it in the live book. The live book, it's also in the GitHub repo. I would like to call out that maybe it's hardware. Sometimes it works in my machine, but it might not work in your machine. So feel free to create issues or ping us. We are in the Erlang Foundation Slack. But we did a demo using Livebook. And how we do that, we basically connected the Livebook to the Raspberry Pi, the steps here. So you have the Nerves app up and running. You connect it through those commands, and basically you can run everything from the Livebook. I found that pretty cool. So the first thing, and probably that was like a very painful point in terms of hardware, is finding the connected camera to the Pi. Oh, Josh is here. Hi, Josh. So one of the issues we wanted to start simple. I had bigger ideas for camera, so I wanted to do this with IP cams. IP cams are usually heavily used in retail, in security. So I was like, yes, Paulo, let's go for an IP camera. But the problem is like eVision was not being able to find the IP camera that we connected in our Wi-Fi or even in the Ethernet. We cable connected everything, was still having issues finding the IP cam. Then was like, okay, so let's go for the Raspberry Pi cam. And we were also having issues in Nerves finding the connected camera. So that is like a Nerves issue. And okay, we need to simplify it more. Paulo came with a suggestion, let's just use a webcam, plug it into the Raspberry Pi, and then we call the Vision for video capturing and finding the camera. So this is still a pain. We don't fully support multiple types of cameras and having the solution out of the box. But after that, we managed to work with the IP camera. So now it works with like a webcam, an IP cam. We are still having issues in making it work with the PyCam. Also depends on the version. And we also had to create a custom image for like the nerve system RPi5 in order to compile a vision, in order to support the IP cams as well. So there are like a lot of implementation details in terms of connecting all the hardware and making nerves like the hub for all of this. Second part of it is processing the input image. So again, we use eVision for implementing the pre-processing. As I mentioned before, we need to resize the image, add the proper paddings. So this is basically calling OpenCV for padding and resizing. After we're ready, after the pre-processing, this is like a very simple pre-processing module that we need to in order to run YOLO. But basically, we used this is like our live book example. Ideally we wanted to use a vision. So whenever I say a vision, again, OpenCV, we wanted to have a vision for streaming the videos for us. That was also being like a very painful process, making it work with nerves. So we simplified again and used Kino for rendering the frames. We used like 50 frames per second. So it was like basically almost real time. In order to render the frames, use capture from the webcam. And here we have this call where we use NX to connect from eVision to the input tensor that we needed to fetch and send it to the Hailo API for inference. And then finally, yay, run the inference with the NIF that we implemented for the Hailo RT, which is basically, again, called Hailo.infer. We have our loaded model. We have our input tensor that was properly pre-processed, and we use NX for doing the backend transfer. And you can set the classes you want to identify and the output keys you want. So that's that depends on the model you want to run it, but this is more specific to Hailo for object detection. And then we need to parse the detected objects by the YOLO inference. This part, big thanks to Alvis Ismail. He is the creator and the maintainer of the YOLO library that we have for Elixir. YOLO is probably one of the most relevant models for computer vision in terms of object detection. So that was really nice in terms of like basically being able to render the objects that were detected. Using eVision would be way too simple and wouldn't provide the expected results that we wanted. So this was a lot of collaboration. And I'm not going to do a live demo, but I'm going to show you this tiny video of us demoing and parsing everything that we had in the live book. So like 95% accuracy that Paulo is a person, great, and a banana is a banana. That's like a simple demo for like how YOLO works. Oh yeah, I tried with Kogan. That worked. So it thought it was a phone, but then it went accurate with photo. Yeah, I really love this picture. Friends forever. Paulo, you're screwed. So this was our demo for Codebean in Stockholm this year. And let's go for the real shit here. What was the pain points and what is the pain points? And there are like tons of them. Before Alex suggested me to present here in this meetup, we talked a lot, wait, go back to this slide. We talked a lot about the frustrations that we had by first, the expectation that we had with nerves. So we thought that nerves would be this magic library that once we connected to the Raspberry Pi, it would be everything out of the box. So finding the devices connected to the Raspberry, and then we could just say in our Elixir land, but that's not exactly how it went. we had to do a lot of like custom implementation in order to have a vision, being able to a vision compiled for nerves, FFmpeg compiled for nerves. We're still having issues in testing with different type of devices, so we don't support different types of cameras. Right now, we have custom configurations for supporting IP cams. We have an out-of-the-box solution for working with webcams, but I really want to make it work with any camera that you want to plug with it, that it's obviously supported by the Raspberry. And a lot of customizations is necessary in order to have it properly working. So it's not easy to load OpenCV or /Vision into the Raspberry using nerves. How it requires like the packages that you need to load and different types of compilations. So that sometimes require like a custom nerves image for the Raspberry. And that again depends on the Raspberry version you're using. The good thing is that the community here is really, really supportive. Again, I could not thank more Frank for stepping up and helping us like deal with things that we were probably very much ignorant. And now Alex, again, you're also screwed because this project, I won't give up on this project. So that was the biggest pain points. But then we are not stopping the library here. Again, it's a very initial project. I really want to make NxHailo out-of-the-box library and really have like a little bit different than nerves, which really requires a better understanding of hardware, Linux kernel, and understanding what nerves can give you and what else you need to do in order to make it work with what you want. I really want to make NxHailo to work out of the box. So you bring your hardware, we have a list of like supported hardware that we can support, you connect it and boom, it's working. That's really what I want. It might take some time. So again, support more cameras, better solution for loading machine learning models. Right now is a little bit of a hard-coded solution where you have to go to like Hailo GitHub models and then you download the model hard-coded in the project. So I want to make it more agnostic. I still envision clustering and making a Raspberry Pi party. We could use Nerves Cloud for that. Josh is here, so maybe it's in a future solution. Imagine having like a cluster of Raspberry Pis and being able to distribute and load balance the ones that are capturing and streaming data, the ones that are actually running inferences. There are also already libraries up and running for that. So we have an X-Serving. And Paulo also released this year Elixir Handoff, which is basically for resource identification and location. So like, oh, I have like 10 Raspberry Pis, I have 5 cameras. We are going to locate resources, like 5 cameras is going to stream, the other 5 is going to run inferences. And we also want to support different acceleration hardwares. So we are doing this with the Hailo, but we are seeing like great hardware being released. So Qualcomm bought Arduino, and they have this new board with acceleration capabilities that we would love to give support. Maybe we could try a demo with NVIDIA Jetson. I don't know. Maybe those different types of hardware we could extend to nerves. Maybe we won't. I'm not exactly sure all this all this possible extensions that we could do with different types of hardware. Because again, nerves is not my main domain system. Mostly my biggest domain system is related to running machine learning pipelines on the edge. So I'm more focused on having computer vision models and how to deal with those models there, but I need to be able to get knowledgeable and skilled with hardware. And that's the hard part, right? Hardware, it's in the name. So that's how I envision. Thankfully, there are like tons of people supporting us. Nerves is still like a very like growing community. People are putting a lot of effort. We are seeing more and more conferences. We are seeing more and more people sharing knowledge. That's very helpful. The more people use it for personal projects, the more we discover problems that we need to resolve. So yeah, that was everything that I had to say. Big thank you, guys. Please don't ask questions. I'm kidding. We can I really want to open this for discussions on how everybody is playing around with nerves or using nerves in production systems. What are the solutions we are seeing around there for edge computation? Because this, again, was a side project that we are carefully envisioning a future, and we want to see maybe companies considering, okay, so this out of the box solution for dealing with like this specific hardware. And it's like the best hardware that we can find out there for edge computation. So there is value on that. And again, we don't need to stop it as a personal project. We want to see this being able to be like a production project. So yeah, thank you all. I will stop sharing my screen.
What camera do you recommend? That's one question there.
We made it work with IP camera. So the IP camera that I have is HomeXi. I think it's agnostic to the type of IP camera, because you basically need to make sure that your IP cam is internet connected and the Raspberry Pi is able to find it. Usually it's able to find any type of IP cam. So I use HomeXi. HomeXi works. Make sure that you plug everything like cable. Don't use Wi-Fi sometimes, that part fails. Apart from that, any type of webcam camera with a USB plug, not USB-C, because the Raspberry Pi USB, I know for sure that works. And we are trying to make it work with the PiCam 2 and 3, both of them. But that is not fully working with the Raspberry 5 image for nerves.
I've got a question. So, Vittoria, you primarily use Raspberry Pis for a lot of this. Have you tried with any other boards and looked at performance differences?
We are about to do it. We are going on an adventure. So let me see if I can share my screen. But recently, Qualcomm released a new board because they bought Arduino. And that board already has acceleration with it. So we don't need to buy any different type of head on top for that. It's impressive what that can do, like how you can plug cameras and mics. So we just bought it. We are waiting because that is on pre-sale. It will arrive in like 2 or 3 weeks. And after that, we will start right away. We, by means like Paulo and I, because we are screwed in this together.
Yeah, so if I may complement that, the plan is to effectively implement whatever implement a specific NX backend that can leverage that hardware, because that's a very long shot assumption, but the idea is that we would be able to at least do accelerated dot products on that specialized pieces of hardware, and if that's possible, then that's already going to be faster than running on the binary backend, and that will win us pre-processing for one. And yeah, we need to explore the hardware basically.
I don't know if you've kept up with what James Harton is doing. Oh, and he's just commented. Yep, he's building nerve support at the moment for the Uno Coup.
Yeah, the bootloader is being a real pain in the ass.
What does it use for bootloader? Is it proprietary or? Oh, wait, is it? Yeah, go ahead. I might have heard a story about this now that I think about it.
It has a apparently has a lockdown EFI that requires us to chain load from ABL to U-boot, microboot to Linux.
Okay, fun.
And at the moment, I'm reduced to like doing binary diffs between the one that's in the Arduino image and what I'm generating from make image, whatever it's called, from the Arduino, from the Android tools. It's not going well.
You said Android?
So it uses the Android bootloader to then chain load U-boot, das U-boot.
At least by the time you get into U-boot, at least it sounds like you'll be having a better time at that point.
Yeah, so using their bootloader, I can get into U-boot and manually boot a build root image, and it works fine. But it's just trying to replace that whole shenanigans with something that is actually open source. Arduino keeps saying the code will be available soon. It'll be available soon, and they have released the kernel patches and things, so that's nice. But yeah, they haven't opened everything, including their flashing code and stuff. So yeah.
So I'm coming from a kind of a place of ignorance on this. How much of the capability of the Pi do you need versus the hat that is doing the inference? The Pi 5 is a pretty capable, small computer. Do you actually need a Pi 5?
Yeah, because you need the NPU to run inference for machine learning models. You cannot rely just on the CPU that the Raspberry Pi 5 provides. That's my short answer. I don't know if Paulo or even Alex have more like details on how to give a better explanation for this question.
I think the biggest constraint for using another board is being able to access the PCIe lanes, because that's what the Hailo HAT uses to communicate. The Hailo chip uses to communicate. If you can plug that in somehow into the PCIe lanes from another chip, I think the Pi 4 chipset does have them, but the standard board does not expose them. But the compute module does, if I recall correctly. So that's an alternative. And there is a question of how many frames per second you would be able to achieve, because there is a bit of pre-processing being done by eVision, but that's done on very efficient OpenCV native code. So maybe that would lower you from like 20, 25 FPS, which is what we had, to, let's say, 15. But really, most of the applications of this project, like image inference and whatnot, would require like 1 FPS, like security stuff, for instance.
Right. Yeah, no, I was just thinking of, the Pi's, the major failure of all those things is the SD card. But moving to a compute module or to something else, that would be awesome, where you have the eMMC, but you can still access the NX, kind of as a coprocessor over a PCIe bus. Yeah, cool.
Yeah, I'm actually new. I'm just watching, being observant here. It's very interesting to me. I work in more like a hardware side, but I haven't tried myself. But I'm interested to see what it is, and then how I can explore further on my own. Yeah. So thanks for sharing. By the way, so is this Arduino? Can that be used yet, or is this only for Raspberry Pi right now?
You mean the NxHailo?
Yeah.
Oh, it's just for the Raspberry Pi. The
Okay.
Raspberry Pi 5.
So I will have to buy that. Okay.
Yes. And not the 4, the 5.
Yep. Thank you.
Yeah, kind of tying into what Paulo was saying, Arduino is Arduino is a completely different architecture. So that's a microcontroller instead of a microprocessor. So it's not going to have any of the I/O or the capabilities. Think, long story short, you need something that's going to run embedded Linux and has a PCIe lane that you can connect to the NxHailo. Oh, actually, I have one around I think it was the eVision code slide. I'll throw out one of those basic ML questions. You mentioned how it was doing the object detection, and you set some of the parameters for how it figures out the bounding boxes and width and height of things and all that. What's kind of the quick answer to how do you figure that stuff out? Because that kind of looks like a bunch of magic variables there that you put in.
You need to figure it out, the params that the model accept. So in order for YOLO to properly detect, you need to set the specific size of the images you're going to have, and the specific bounding boxes for it. So it all comes, it really depends on the model you're using, and then you adjust the parameters for the pre-processing of it. So for YOLO is like pretty standard in order to create some specific rectangle images at the proper padding, and how you create the bounding boxes around the size that you set. But that will differ for every model that you use. So if you use Dino, it will require different parameters. All that I recall right now is basically computer vision models. So I'm really sorry. I'm not sure about other models such as Whisper, how would be the parameters that you got to add to run the model, and make sure that the model is running on the proper setup that you have. But yeah, I will share on the slides, and then there are comments for the pre-processing that was implemented on the live view, so that will make it easier to follow.
Gotcha. So it sounds like if somebody just grabs this out of the live book, there's still a little bit of tuning that's involved there. It might not work. The app might run out of the box, but based on what they're trying to do with it, there still might be some tuning involved to actually make it do the detection they want it to do.
You still need to know exactly what you're going to run. So if you're going to run object detection and you want to use YOLO, you need to at least understand the inputs, the input tensor, and how your input shape should be in order to run it. So it's not that out of the box. The hardware wise, that's a good explanation. Hardware wise, it would be great for this to be out of the box. Machine learning pipelines, it's not that out of the box. You need to know at least because you can load multiple models on the Hailo NPU. So you can load Hailo, but you can also load another one, and that's going to be like a totally different type of pre-processing. It's not exactly tuning, because tuning is more related to how you want your model to respond to the inferences. It's more pre-processing and how you're going to post-process, and that really depends on each type of model you're going to load.
Gotcha. And if you want to detect Coke, you're just out of luck.
I'm sorry, come again?
If you want to detect Coke, you're just out of luck.
Yeah.
Yeah. Oh, Moses says, how mature is NX for production?
NX itself, I'd say it is very usable in production. We do use it at TV labs. We are missing only a few things on our checklist for NX 1.0, which hopefully will be released next year, early next year. And yeah, I'd say NX itself is pretty mature. Last week, I also released the first not so mature version of EMLX, which runs on the Mac GPUs, if you do have a Mac and want to test NX out. And NxHailo, I think that's a different question. But as Vittoria was saying, it's a bit finicky if you want to do anything different than using the standard NERS or Pi5 image and just use webcams or IP cams. But if you want to do the standard stuff, it's pretty usable as well.
I mean, if we asked Lars is also one of the main contributors to nerves. We asked Lars before we started that, and he was like, "Yeah, it works on my machine," and it wasn't working on anyone's machine. So we're confident on saying like, yeah, you can try out our repo and run it, and it will work. Some tweaks might be needed, or you got to check the hardware that you have, but it will work.
Lars, don't listen to that. Put this in the newsletter. Thank you. Cool. Well, sounds like that's about it. Once again, Vittoria, thank you so much for doing this. This was awesome to see what you've been doing with Hailo and NX and all that stuff. And Paula, thanks for coming out as well.